Today we are going to discuss p block elements. P block elements are placed in group 13 to 18. The general electronic configuration is Ns2 Np1 to 6. The groups included are 15, 16, 17 and 18. And now group 15 you will study in 11th, and in 12, 16, 17 and 18 only. Now you can see the picture. Here p block elements, as you all know, includes metals, metalloids and non-metals. Group 15 elements are also called nitrogen family. The configuration is Ns2Np3. The elements of group 15 are nitrogen, phosphorus, arsenic, antimony, bismuth. Now group 16 element are also called as oxygen family. The group 16 elements of the periodic table consist of oxygen, sulfur, selenium, tellurium and polonium. The general electronic configuration is Ns2Np4. Here you can see the electronic configuration of all the group 16 elements. Oxygen you can represent like this. In all the configuration, you can see the general configuration is Ns2Np4. Now when we look into the general periodic trends of the periodic these group elements, इनके अगर trends को देखें हम तो atomic radii अगर हम देखें तो down the group increases, electron negativity decreases down the group, ionization enthalpy will also decreases down the group, electron affinity or ability of the atom to accept an electron decreases down the group. Melting point also increases down the group. As we all know, as the mass increases, melting point will increase. Boiling point increases down the group. Mass will increase, then the boiling point will also increase. The general electronic configuration is Ns2Np4. The most common oxidation state of this group element is -2 or -2 +2 +4 and +6. Now look into the chemical properties of some chemical properties of oxygen. Oxygen, like when it reacts with sulfur, it forms sulfur dioxide. इस ग्रुप में सल्फर भी है, सल्फर ऑक्सीडाइजिंग एजेंट HNO3 के साथ रिएक्ट करके क्या फॉर्म कर लेगा, आप देखो H2SO4 बन जाएगा. नाइट्रिक एसिड क्या कर रहा है, सल्फर को ऑक्सीडाइज कर दे रहा है. विथ अल्कली इट फॉर्म्स नाइट्रोजन सल्फाइड और Na2 गैस बनती है. विथ नॉन मेटल, these are the reactions of these group elements. Metallic character increases as we descend the group. Oxygen and sulfur are typical non-metals. Selenium and tellurium are metalloids and are semiconductor. Polonium is a metal. Tendency to form multiple bond decreases down the group. Formation of hydride. All the 16 elements forms hydride. The stability of the hydride decreases as we go down the group. Except H2O, all the hydrides are poisonous, foul-smelling gases. As you know, H2S, it's a foul-smelling gas. Acidic character and reducing character, as we go down the group, it will increase. Why it will increase? क्योंकि MH bond angle, bond length बढ़ेगा, then the boiling point, then the acidic character will increase, because tendency to lose H ion will increase because MH bond will break easily. Boiling point also decreases from H2O to H2S. Since in H2O you can see hydrogen bonding is present, so H2O की boiling point ज़्यादा होगी H2S से. Now these are some dihalides or halides of these group elements. They also exist in dihalides, tetrahalides and hexahalides. They exist in the form of monooxides, dioxides and trioxides. Anomalous behavior of oxygen. If we point out the anomalous behavior of oxygen, oxygen is gas, all are solid. Oxygen is diatomic, others are polyatomic. Oxygen is paramagnetic, others are diamagnetic. Oxygen can form hydrogen bond in hydrides, alcohol and carboxylic acid. Form p-pi multiple bonds. Oxygen exists in -2, +2 only with fluorine and others. It will exist in +2 and +6 state. Form ionic compounds. Oxygen can only form ionic compound in this group. Now these are few reactions of oxygen. How you can prepare oxygen? These from KClO3 you can prepare oxygen. Now next element of this group is sulfur. As you know, sulfur exists in the form of sulfides, sulfates, H2S in volcanic gases in proteins. Allotropes of sulfur, rhombic sulfur. This allotrope is yellow in color, melting point. You can see 385.8 Kelvin. Rhombic sulfur crystals are formed on evaporating the solution of raw sulfur in CS2. It is insoluble in water but dissolves to some extent in benzene. Monoclinic sulfur. You can see the structure of this allotropes. These are few reactions of sulfur. Oxyacids of sulfur. Oxyacids of sulfur, these are few structures of oxyacids of sulfur. As we know कि जितने oxy acid है, oxygen is directly linked with hydrogen. These are the structures. You can see the structures. Thiosulfuric acid and polythionic acid. Now group 17 element. The halogen family, it is also known as halogen family. General electronic configuration Ns2Np5. Here are the general electronic configuration of these elements: fluorine, chlorine, bromine, iodine and astatine. Now you can see the orbital diagram. Reactivity. The radio acceptance of electron is the reason for the strong oxidizing nature of halogen. F2 is the strongest halogen and it oxidizes other halide ions in solution. These are few reactions of halogens. Reactivity of halogens towards other halogen. Halogen combines among themselves to form a number of compounds known as interhalogen compounds. You can see these are the types of interhalogen compounds. These are few structures, this ClF3, IF7. The compounds can be used as non-aqueous solvent. Interhalogen compounds are very useful fluorinating agents. Oxyacids of halogen. Due to high electronegativity and small size, fluorine forms only one oxyacid HOF known as fluoric acid. Hypofluorous acid, the other halogen, forms several oxyacids. Most of them cannot be isolated in pure state. Now these are few structures of oxyacids of chlorine. Now group 18 elements. Helium, neon, argon, krypton, xenon, and radon are group 18 elements. They are also called noble gases. The general electronic configuration is Ns2Np6, except helium, which has electronic configuration 1s2. They are also called noble gases because they show very low reactivity. All noble gases except radon occur in atmosphere. The atmospheric abundance in dry air is by 1% by volume, of which argon is the major constituent. Helium and sometimes neons are found in mineral of radioactive origin. Now, these are the general electronic configuration of these group element Ns2 Np6. Ionization enthalpy. Due to stable electronic configuration, these gases exhibit very high ionization enthalpy. If we look at atomic radii, increases down the group with the increase in the atomic number. Electron gain enthalpy. Since noble gases have stable electronic configuration, they have no tendency to accept electron and therefore have large positive value of electron gain enthalpy. Now if you see the physical properties, all noble gases are monoatomic. They are colorless, odorless and tasteless. They are sparingly soluble in water. They have very low melting and boiling point because the only type of interatomic interaction in these elements is weak dispersion forces. Helium has the lowest boiling point of any known substance. It has an unusual property of diffusing through most commonly used laboratory materials. Now if we look at the chemical properties, noble gas except helium have completely filled Ns2Np6 configuration. They have very high ionization enthalpy and more positive electron gain